Hey, this is Mr. Aiden. We're back with Unit 7 differential equations, and we're going to verify some solutions of diffie-q's. So let's take a look at what verifying solutions actually means. We kind of got into this a little bit in the last video. It's kind of taking the next step with diffie-q's, and you can see here I have a differential equation. It says the slope, the dy over dx of the tangent line, is equal to 2y over x, and this is called a differential equation. And so we want to know, is y equals 2x a solution? Well, let's try to see whether this is or not. So we're going to take the derivative of both sides. So we're going to do d over dx to both sides. So we get dy over dx, the derivative of y, and is equal to 2 and dx over dx, which is just 2. And so I know dy over dx is equal to 2. I know 2 times y. What is y equal to? It's 2x over x. So what do we have? We have 4x over x, which is 4. That does not equal. So this is not a solution of this differential equation. It's just not a solution. When we take the derivative and we plug it in our differential equation, it does not work. And so we're kind of trying to evaluate to see if it works. So let's take a look. What about y equals x squared? Well, what is dy over dx? What's the derivative of this? Is 2x. So let's plug this in and see what works. dy over dx is 2x, and 2 times y. What is y? Y is x squared over x. So we get 2x squared over x, which is 2x. This works. Yay! That is a solution. This is a solution. It might not be the only solution, but it is a solution. It is analogous to you taking a number, putting it in a equation, and seeing if it becomes 0 in a polynomial. And so you by, like, say, synthetic division or something like that. And so we're verifying to see whether this is correct. So let's try another one. Is y equals 2x a solution for this? Well, what do we know? We're going to take the derivative. dy over dx, or y prime, is equal to 2, isn't it? So y prime is 2. Y is equal to 2x minus x. What's 2x minus x is x. This does not work. So this is not a solution. This is not a solution of my differential equation. So let's try another one. Let's try this guy right here. And we're going to do y prime equals 1 plus 0 plus e to the x. So y prime is 1 plus e to the x. Let's see if this works. It says y. What is y? Y is x plus 1 plus e to the x minus x. So what's x plus 1 plus e to the x minus x? Well, the two x's cancel out, and we're left with 1 plus e to the x. 1 plus e to the x. Ding, 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 ding. This works. Yes, this is a solution for my differential equation, because when we took the derivative, we plugged everything in, they equaled each other. Okay? Well, let's try another one. Remember, I said this wasn't quite just the only solution, is it? Let's try this one down here. Y equals x plus 1. So what's y prime? Y prime is 1 plus 0, or y prime is equal to 1. So y prime is equal to 1. What is y equal to? They told me y is equal to x plus 1 minus x. What cancels out is the x's, and we're left with 1. 1 is equal to 1. Ding, 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 ding. That works as well. There was two different solutions to this differential equation. This one right here was a solution for my differential equation, and this one right here was a solution for my differential equation. There was two different solutions to my differential equations that worked when I tried them. So let's try one more example. And so here we have a differential. It is dy over dx equals negative x over y. And we're going to take a look at two different types of solutions, see if these are solutions. One or both, or neither of these are solutions. I don't know. So I'm going to take the derivative of the first one. Dy over dx equals negative 2x. So this would be negative 2x. We have negative x over y. What is y? Is negative x squared. The two negatives cancel out, and you're left with 1 over x. Does negative 2x equal 1 over x? Heck no. So this is not a solution of my differential equation. So let's take a look at one more solution, possible solution. We have y equals the square root of negative x squared. So that is negative x squared to the 1/2 power. So remember, rearranging it does help out with my derivatives. So we have dy over dx equals 1/2 negative x squared to the negative 1/2, that's the power rule, times the derivative of the inside guy, negative 2x, the chain rule. So my dy over dx is equal to the 1/2 and the negative and the 2 cancel out, so we're left with negative x times negative x squared to the negative 1/2 power. Or you could say negative x over the square root of negative x squared. Okay? The reason these two negatives don't cancel out is there is a radical over that negative x squared right there. So, what is this guy? He's negative x over the square root of negative x squared. And what do we have? We have negative x. Well, that's looking good. We want a negative x over y. What is y? Is the square root of negative x squared. That is exactly what I have, which means that is, yes, that is a solution for this differential equation. So I hope that helped out. We're basically taking derivatives and plugging them in an equation and seeing if it works. That's all we're doing in verifying solutions of differential equations.